Hello, this is Keith Graham from Codasip. I'd like to introduce you to several new variable types that you'll be using in CodAL, which is the processor description language used in Codasip Studio. Similar to C, you have different types of variables to declare. In C, you might be familiar with integers, unsigned integers, as well as strings. But there are several new types that you'll be using in this course to describe your processor. Now let's take a look at the first one, which is the signal type. The signal type is used to define a signal which is connecting 2 points. There's no storage element, it just connects 2 points, so it's a signal. And to declare this type of signal, we have the format right here. And an example would be signal bit. And I'm going to make this a logical signal. It says true or false. And we have already defined in your processor a definition of Boolean bit, which is defining, well, it's a number one. So we're defining that this signal is 1 bit wide. And we're going to call it signal. And the S stands for that it's a signal, and it's a nomenclature that we use. The ID says it's this signal resides in the instruction decode stage of your processor, and it's going to be reg write. So that's how you declare a signal in CodAL. Now let's take a look at the next type of variable type in CodAL, register type. For the register type, we actually have an optional value you can put at the end, which is the optional assign its default value. So let's take a look at the register type example up here. Here's the basic format. And if you look at the very bottom here, we have an example of using a integer unsigned 16-bit declaration and setting a default value of 0. So we're going to do something very similar to that as our example for register type declaration. So first of all, I need to declare that it's a register. So it's going to be register bit, and I now have to say how many bits wide. And we actually have defined already in your project something called word W, where you can define, well, it's defined in another HCodal file that is equal to 32, because we're talking about a 32-bit wide machine. Now, after I've done the register declaration type, its width, I need to give it a name. And I'm going to give it the name of PC. So R stands for register, P for program counter. And now I want to give it a default value. So I'm going to do a curl bracket, default equals 0. And that's how I can define a register type using a default. Very similar features, just like you were declaring a unsigned variable in C. Now let's take a look at what makes a pipeline register unique in declaring it in CodAL, the processor description language that you're using, versus the standard register declaration. The pipeline register has 2 additional inputs that you can program. One is the clock enable, and the clock enable is used to stall the processor. If the clock enable is deasserted, on the next rising edge, the register will not clock the input in and move it to the output. It will just retain its current value. The other input is the clear. If the clear signal is asserted, on the next rising clock edge, all the outputs will become 0. And this is how you insert what's called a no-op bubble into your pipeline if that is required in your design. Now, let's take a look at the declaration of a pipeline register. It looks a lot like the register declaration, but at the end, you're going to actually specify that it's a pipeline. So let's take a look at an example. I'm going to take a signal such as the output of the ALU and store it into its pipeline register between the execute and memory stage. So first of all, I have to do, just like a register, I have to do register bit. and I have to do the number of bits. And in this case, I'm going to do word W, which is, we already talked about, that's defined in our system as 32 bits wide. Now I'm going to start with R, just like a register you would in nomenclature for the name of it. Then the next part, you're going to actually specify what is the pipeline that it's associated with, which is EXMEM. It's the execute memory stage pipeline. It's the pipeline where the inputs are from the execute stage and the outputs are into the memory stage. ALU results. So that is my register name. Now I also need to add pipeline into its specification, which is open bracket pipeline equals pipe, and it's the EX mem stage, semicolon, close bracket, semicolon. So that is specifying that when you use the control signals for stall for the pipeline stage EX mem or the clear for that stage, it will affect this pipeline register. So hopefully this video will help you understand how to declare registers, pipeline registers, and signals. If you like this video, please subscribe to this channel so you can be notified when additional videos are published. Have a great day.